Hello students. Today we're going to go through how to use a TI-83 calculator. So you're going to need to know how to use specifically a TI-83 or a TI-84 calculator because you will not be allowed to use your phone during an assessment in Pre-Calc 11 or Pre-Calc 12 under normal circumstances. So we're going to go through how to use a graphing calculator, which was part of the technology piece of Pre-Calc 11 today. If you do not have a TI-83 calculator or a TI-84 calculator, that is okay. You do not need to go run out and buy one. You can use one of the apps that I have attached to the computer. Or to the website. So if you download that TI-83 calculator, that's great. Desmos is a lovely, lovely online program or an app on your phone. However, it's not going to teach you how to actually use a TI-83 calculator. So you don't want to use that for this. You want to get out that TI-83 calculator or the app. There is apparently an app you can get on your phone as well that exactly mimics and looks like a TI-83 or TI-84 calculator, but it's not free. So I'm not providing that as a source, but you have to pay for that. I think it's like $2.99. So this is the link that I've given you is how to download a free TI-83 calculator to your computer, and it will look like the one I'm going to share with you now. Okay, so here's your beautiful TI-83 calculator. We're going to go through those notes that were in your note package on how to use graphing using technology is page 81. And that's how we're going to start with the first step. We're just going to go through that. You don't need to use this video to go through that. If you're understanding the steps and you don't need me here doing this, you don't need to watch this video. Just go ahead, follow those steps, use the calculator. That is the goal of today's mini lesson. So the first thing we're going to do is enter an equation. So when you open your graphing calculator, it will be on a screen that looks like this. Oops, not that, like this. All right, it might have some words on it saying welcome to using this, whatever. You're just going to go straight to that Y equals button. It's in the upper left-hand corner. Now, if you're physically using a graphing calculator, it's going to store whatever was used on it before. So you might have to clear something on this screen, or you might have to turn stat plot off. There's a whole bunch of other things that you might have to do if it's an actual real calculator, a real life calculator. But we're just using, if you're using the app one, it automatically clears it when you close it. So you're going to have a blank screen here. If it's not blank, you're going to hit clear button, which is just below the down arrow, or you can hit the DEL, the delete button, which is to the left of the left arrow button, and just make sure it's blank like it is here. Okay. We're all going to enter the same equations. We're going to go bracket x, and there's that little xt theta n button. So you're just going to hit that button. It's just below the mode button. Then you're going to go -3 end bracket and squared. So graphing calculator is actually a square button. If it was anything other than squared, if it was to the power of 3 or to the power of 4, you would actually have to use the little hat thing, little hat button. Sante circumflex, I think. I don't know. Please don't judge my French. And then go like to the power 6 would look like that. Okay, luckily, I am super nice, and we're just going to use squared. So there's a squared button right beside the comma in the outermost left column of buttons. All right, so then you are going to graph. The graph button is in the upper right-hand corner. You're going to hit that graph button, and it's going to graph a beautiful parabola for you. So you can there's a whole bunch of different functions on this. You can zoom in and zoom out. You can also manually adjust the windows to zoom in and zoom out on this parabola. So that is going to be the second page of instructions on how to adjust the window of your TI-83. The steps for a TI-84 are almost identical. Okay, so you're going to go to zoom, which is the middle up button, and the zoom standard is going to give you the standard window of going up 10, going out to 10, going out to -10, and going down to -10. So every direction on the X and Y axis goes to a maximum or minimum of 10 or -10. So that is option 6 in this zoom menu. You can either scroll down like by hitting the down button, on your computer, you can cheat and just hit the down button on your computer, or you can hit the number 6. So to me, hitting the down button 5 times and then the enter takes a lot more effort than just hitting the number 6 button. Just hit the number 6. All right, so there we go. It was already on a standard window, but that's what the standard window was. Anytime you're stuck and you have no idea what's going on with your scale, you can't see something, just go zoom 6 and have it go back to the standard window. It kind of just resets everything and gives you a chance to refiddle with everything. All right, so you're going to now hit zoom out. So we're going to go back to zoom, hit the zoom button. Then we're going to go to that number 3, zoom out. So you can either hit the down button to get to zoom out, or you can just hit number 3 and it will do that for you. It didn't really zoom out that excitingly. So you can hit zoom out multiple, or actually I think I did, So it's not that exciting. You have to keep hitting it a bunch of times. Mine's not even zooming out very well. I'm going to try the zoom in. And then zoom in, zoom in. That doesn't look like it's zooming in. It works on an actual calculator. I guess maybe the functionality isn't working on this app. I'll be honest, I don't use the zoom in or the zoom out function. I just manually adjust my window. So that's what we're going to do next. So it says, what is a window? It's actually just what, and I can't, see how my window is like this, and it's going from one hand to another hand. If I zoom in, I'm making it so that it's going like this, so that you get a zoomed in version. That's all it means. And if it's zoom out, it's adjusting the window out. So we can manually do that by hitting the window button, and you're welcome for that wonderful display of, I don't know what that was, interpretive dance maybe. All right, so you can go into the window button. It's the second to the left button. It says window. When you click that, it's going to have a bunch of things: X-min, X-max, X-scale, Y-min, Y-max, Y-scale, X-resolution. You're not going to touch the X-scale or the Y-scale. That's just saying what each little notch is worth, or the value of it. You just want each value to be 1. Don't play around with that. It's going to really mess up your day. You use that when you're doing things with stat plots and doing histograms and using standard deviations. That's when you're going to start mucking around with your scales. But for parabolas and quadratic functions, leave them alone. Don't touch them. All right, so you can manually change how far down the X scale will go, and you can change it to how far up it goes. So let's just play around with that. This is in the directions. We can go to negative 100, go up to positive 5, and just look at what that looks like. So all I've done is adjusted the X scale, so Y is normal, but look how tiny my parabola is. That's because I've made this negative part of the X axis to negative 100. It's super long. The other thing to note is for the negative, you have to use this button down here to the left of the enter button for a negative, and this button above the plus for a minus. If you were to go minus 100, it's going to give you, even though math, minus 1,000, it's going to give you an error message because it doesn't like it. Oh, mine didn't. The actual physical graphing calculator, not the app, does not like this, and it will give you an error message. You have to use the minus button. Oh, see, it automatically changed it for me. How nice of it. Okay, so the computer app automatically changes it for me. The graphing calculator, the actual physical graphing calculator, is not that nice. All right, so you need to remember to do the negative sign. All right, so if I were to just change that back to negative 10 and positive 10, so there's my standard window again, and I was to change my Y's, so that's how far up or down the graph goes, and maybe I go from negative 5 to 100, and I look at that, this is what it's going to look like. So you get very little below the x-axis because I made that only worth 5, and I made the part above worth 100, so here it is really flowed out. Anytime I just want to change things, and I don't want to deal with all the kerfuffle that I just did, I'm going to go zoom 6 to reset it to that standard window. That's the only way I use the zoom function. Okay, here's the important part. you need to adjust your window so that you can physically see the points of interest on your parabola. You need to be able to see the y-intercept if you want to find the y-intercept. You need to be able to see the x-intercept if you want to see the x-intercept. And you need to see the vertex, which happens to be the same thing as our x-intercept here, if you want to get the vertex, okay? So we're going to find the vertex first. That means that we want our graphing calculator to calculate something for us. So if you look above the trace button, it says in yellow calc for calculate. So you're going to hit second function trace, and it's going to give you the calculate menu. All right, we want to find the vertex. The vertex will either be a minimum or a maximum value. So we need to know that when it opens upwards, we're looking at a minimum value. And we need to know when it's opening downwards, we're looking for a maximum value. This parabola is opening up. So we need to pick minimum. So that is number 3, okay? And then it says something like left bound. So you're gonna move the cursor. You see that little flashing little dot thing that's on the parabola? It moves along the parabola. It will give you all the different values for x and y that fall on that parabola. You need to move that cursor close to the vertex. So here it looks like it's on the vertex. I'm going to go to the left of it. If I'm going to be really exaggerated, I could go here. That is very much to the left of the vertex. It's not the best. You want to get as close to the vertex as possible while staying to the left of it. So I'm going to go, I think this is the vertex right here. So I'm going to go one more to the left. I feel that's to the left. And I'm going to hit enter. And then all of a sudden it says on the screen, right bound. So then you're going to move the cursor to the right of the vertex. So here I think it's on the vertex. Here I think it's to the right of the vertex. And now I'm going to hit enter again. And there's these 2 little arrows. If you can see on the screen, the upper right-hand corner, there's these 2 little arrows pointing towards each other. And there's very little space in between them, which means I've gotten my cursor very, very close to the vertex on both sides. And now it says right here on the screen, guess, question mark. I don't want the graphing calculator to guess. I want it to calculate. I have a little issue with the programming on this one, but you're going to just say enter. So you're going to hit enter again without doing anything else after that stage. And then there you go. It pops up with a value. It says minimum is x equals 3 and y equals a whole bunch of stuff, e negative 16. This is 1.425 times 10 to the negative 16. So it's 0.00000000000001425, which is essentially the same thing as 0. Sometimes it's nice and just pops up with a 0. So our minimum value, the vertex happens at x is 3 and y is 0. All right, so that is our vertex, 3, 0 in a coordinate point. And that's how you find the vertex. Now we're going to find the y-intercept. So again, we want our calculator to find something to calculate it. So we're going to go second function, trace again to get that calculate menu. And this time we're just going to hit value. Okay, so we're going to hit number 1. And we're going to put a value in for x. And it's going to tell us the value for y. Because remember, x is kind of an input for a function and y is the output. So we can just put in a value for x and calculate y with no algebra, and so can the calculator. So the y-intercept happens when x is equal to 0. So you're going to hit 0 here on your calculator, and then you're going to hit the enter button. And it's going to tell you that the y-intercept happens when y is 9. So the y-intercept is 9. And that's how you find the y-intercept. The most straightforward way. I love it. All right, this next one is how to find an x-intercept. To do this one, I'm actually going to change my parabola a little bit because we actually already found the x-intercept because the x-intercept and the vertex for this specific function was the same point. So I'm going to go back to y equals, and I'm just going to add a minus 9. And then I'm going to graph that one. There we go. So this one will have a new vertex. This one will have a new y-intercept. And this one will have or maybe I don't want to do -9. This one will have a new x-intercepts as well. I'm going to go -7 just so that we don't have any overlap. There we go. So this one has a different vertex again, a different y-intercept again, and because it crosses the x-axis twice, it has 2 x-intercepts. So we're going to use this one. I just add a -7 to the end of that other equation, and we're going to use this one to find our x-intercepts. So again, we're going to go to that calculate menu, so second function trace. And this time we want to find zeros or roots. They're called zeros for a function. They're called roots for an equation. They're the same thing. They're the point in which the parabola goes across the axis. There's actually a slight difference, but essentially the same thing. So you're going to hit number 2 for 0. And here it's going to do that left bound, right bound guess thing all over again. So you're going to do left bound, right bound guess for both x-intercepts. So here's my cursor. I'm just going to move it back and forth so you can see it. And I'm going to move it to the left of that x-intercept. So the x-intercept is to the point that it hits the line. So the left portion of that is above the x-intercept. So here it is above the x-intercept, and that is to the left of the x-intercept. So I'm going to hit enter here. And then I'm going to go to the right. So the right for the left x-intercept is below the x-axis. So it's over here. I'm going to try to get as close to that x-intercept without going over. I'm going to go here, and I'm going to hit enter. And it's going to tell me my 0 happens when y is 0. We already knew that. When x is equal to 0.3542489. Now, the graphing calculator has rounded that off. This is a number that probably would be irrational and include a radical if we were solving for an exact value. So it's important to know when we're using technology to find data, sometimes we end up losing precision. So the answer for this 0 is 0.354. If you're rounding to 1 decimal, you would say it's 0.4. Okay. So great, we found one x-intercept. Now we have to do the exact same thing for the intercept on the right. So we're going to go second function trace again. We're going to hit number 2 for 0 again, and it says left bound. So now we got to move the cursor all the way down and back up, and we have to go the left of the x-intercept on the right one on the parabola. So for the x-intercept on the right, to be left bound, you're going to be below the x-axis. So that's right here. This is getting as close to that x-intercept without going over it. I'm going to hit enter here. And to the right of the right x-intercept, to be right bound, is going to be above the x-intercept. So it's going to be over here. But again, I want to move that cursor as close to the x-intercept as possible without actually going onto it. And I'm going to hit here. And then I'm going to say, yes, please guess the answer. And it's going to pop up that answer for me. So this x-intercept to the right, because there was 2 x-intercepts, one left, one right. The right one is when x is 5.6457513, and of course when y equals 0. So if we were rounding this off to 1 decimal place, we would say this 0 happens at 5.6, 0. And that is how you find the x-intercepts, y-intercept, and the vertex of a parabola. It's important to remember that a parabola, because it's two-dimensional and goes up and down, or up and down this way, that it can have either 2 x-intercepts like we just saw, or it can have 1 when it's just resting on the x-axis, or it can have none. Okay, so there's a bunch of options for that. So just to reiterate that, if a parabola looks like this, or you can have ones that go like this, it's crossing the x-axis in two places. So it has 2 x-intercepts. If you have one that looks like this, and this is kind of hard for me to sketch because, as we know, my sketching skills are a little bit questionable. It only touches the x-axis, at 1 point, which is its vertex. That means this parabola that I've drawn in red only has one x-intercept, and it's the same as its vertex. I can do that upside down. All right, so just 1 point the vertex is resting directly on. Okay, that's usually, if you see it in vertex form, there isn't a plus q because it hasn't gone up or down. It hasn't been shifted up or down. And then, of course, you can have these ones that look like this or like this. Even though they're crossing the y-axis, the way I've drawn them, they're not the minimum value for the top one here. The minimum value is above x equaling 0. It's above y equaling 0, sorry. So the minimum value is not below the x-axis, so there will never be an x-intercept. And the same can be said for this one down here. The max value for this is not above 0. So the max value, if it's a negative max value and it's a parabola that opens down, there will not be an x-intercept or 2. If its minimum value is above 0 and it's a parabola that opens up, it again also will not have any x-intercepts. And that's something that we're going to keep working on through this. So it's not like you're going to get a crash course on this tomorrow. What I'd like you to try to do with your TI-83 is to practice those 3 equations. I actually have more. I have D, E, F, and G as well on this page, but I want you to pause the video here. I want you to try to manipulate the windows and graph these parabolas and practice finding the vertex, x-intercept, and y-intercept. And here's the answers for those first 3. And then, of course, there's some questions in the textbook, one question in the textbook that you can give a go for using your TI-83. Quick note about sketching and how we sketch our results. I was cheating a little bit in the ones you just saw up here, in that I just did a screenshot of my actual graphing calculator. But generally what you do is you graph the parabola. So if we were going to look at the one that we had just before, it was on a standard window. So you would sketch your x and y, your y and x, and you would say, well, this was the y max was 10, the x max was 10, the y min was -10, and the x min was -10. And that tells anyone, including yourself, when you go back to your notes, that, hey, this was the window. Because there's nothing like having to go back to a question and then having to refiddle with the window just to find things. If you record the window in your sketch, you will never have that problem. It will never be there. And then for our parabola, it kind of looked like this, right? And we found those 2 x-intercepts. I believe this one was at 0.4. And this one was at 5.6. I'm going off memory. Please correct me if I'm wrong. And we didn't find the vertex or the y-intercept for this particular one, but that's how you would document it if you were sketching your answer, having to show your answer in written format. I hope you found this helpful. Please let me know if you had any questions. I hope you guys are all doing well. Take care and goodbye.